Right, so this is a question on algebra, and the question is um, if if x plus 1 is a factor of fx, which we've been given is 4x cubed plus 3x squared minus 4x plus k, then what is k? This k over here, what is it? So this is very easy to solve using something called the factor theorem, right? So what does the factor theorem say? So the factor theorem simply states that, I'll just write this in blue so that it stands out. So the factor theorem simply says that if, generally speaking, if x minus a is a factor of uh, fx, and fx is some polynomial, so this is some polynomial, right? Which basically means there are lots of terms like x squared plus x cubed and things like that, you know. So it's something like that. Then f of a is equal to 0. So if it's a factor, then f of a is equal to 0. Now the proof of this is really simple, and it's taken up in one of the lessons on algebra. So I won't go into the proof over here. I will just use this fact in this question, right? So I'm just going to use this fact of factor theorem in this particular question. So how does it apply here? Well, if x plus 1 is to be a factor of the fx that we had been given, so what is x plus 1? Well, x plus 1 is the same thing as x of minus 1, right? You can write it like that, and the reason I've written it like this is so that we can compare it with x minus a. So we had written x minus a is a factor of, so let's just compare the shape of this x minus 1 with x minus a. So if it's written like this, then it's obvious that a is equal to minus 1, right? So so what have we learned? Actually, I should switch back to white. So because I've started solving the problem again. So so what does this mean? Well, if x plus 1 is a factor of the fx that had been given, then f of minus 1 will have to be equal to 0, which means that 4 times minus 1 raised to the power 3 plus 3 times minus 1 raised to the power 2 minus 4 times minus 1 plus k will have to be equal to 0, right? So minus 1 raised to the power 3 is simply minus 1, so which implies that minus 4 plus 3 times minus 1 raised to the power 2 is just plus 1, so plus 3, minus 4 times minus 1 is plus 4, and then we got the k that we're looking for, plus k is equal to 0. That's what it'll have to be. Now there's a minus 4 and a plus 4, so they cancel out. So what do we have? What we have is k plus 3 is equal to 0, which implies k is equal to minus 3, right? So if x plus 1 is a factor, so this is if x plus 1 is a factor, then fx would have to be equal to 4x cubed plus 3x squared minus 4x minus 3, right? So x plus 1 is a factor of this expression over here. So this was an example of how to use factor theorem to find k, and it's kind of easy to do, and in case you need to go back and see that lesson on factor theorem for the proof of why this condition exists, right? This condition in blue. So that was the question, and that's how it's done.